Welcome friends to this session 4 on gear trains. In this session we are going to solve a more complex problem. Students who haven't yet viewed sessions 2 and session 3, kindly go through them because it will help you to understand this sum in a much better way. So this is the sum that we are going to pay attention to. Here gear C and gear D are compound gear, which means they are mounted on the same shaft, and also means speed of rotation of gear C and that of gear D are same. Gear C is meshing externally with gear E, while gear E is meshing internally with gear A. Gear D is meshing externally with gear F and it is meshing internally with gear B. C and D is a compound gear. E is meshing externally with B while it is meshing internally with A. F is meshing externally with D while it is meshing internally with gear B. This arm G that you see over here, it is rotating about this pivot point O and it is carrying gears E and F at its ends. The data that is given to us is number of teeth on gear C is 28, number of teeth on gear D is 26, number of teeth on gear E and gear F is 18. We need to find the number of teeth on the internal gears A and on the internal gear B. Similarly, they have also asked us to find the speed of internal gear B if it is given that the arm is rotating with a speed of 100 rpm in the clockwise direction when internal gear A is fixed. That is why we have over here the speed of the arm, that is n suffix g, where g is denoting the arm. If n suffix g is equal to minus 100 and if the internal gear A is fixed, which means n suffix A, if it is equal to 0, then what is speed of gear B? Similarly, they also want us to find the speed of gear B when the arm is rotating with 100 rpm in the clockwise sense, but in this case, if the internal gear A is rotating with a speed of 10 rpm in the anti-clockwise sense. So let us get started with solving this sum. So we'll start with the first part. In the first part, we need to find actually the number of teeth that are there on gear A and on gear B. Now, we have already looked in detail how to calculate the number of teeth on gears in session 3. So here we will quickly run through it without paying much attention. So now if you pay attention in this particular diagram over here, then radius of gear C. See, C is meshing with E and E is meshing with A. So therefore radius of gear C plus diameter of gear E will be equal to radius of gear A. That is what we have over here. Now this formula, making use of this formula over here, where radius is equal to module into number of teeth on that gear divided by 2, then here this will be module into number of teeth on gear C by 2. Now this diameter of gear E, this is nothing but 2 times radius of gear E, and radius of gear E is equal to module into number of teeth on gear E divided by 2. Radius of gear A will therefore be equal to module into number of teeth on gear A by 2. Now if you look at the 3 terms that are there, then module is common throughout in the numerator, while 2 is common throughout the denominator. Now this is module is same for all gears, that is what they have given us to us in the question. So let us cancel out module from the numerator of each term and this numerical term 2 from the denominator of each term. Then what we are left is number of teeth on gear C plus 2 times number of teeth on gear E is equal to number of teeth on gear A. Now number of teeth on gear C is equal to 28. Number of teeth on gear E, from given data it is equal to 18. This is therefore equal to, how much is this? 28 plus 2 into 18, which should be equal to 64. So number of teeth on gear A is equal to 64. I will make a note here. Now we need to find the number of teeth on gear B. Therefore, now let us look again in this diagram. Here gear D is meshing with gear F while F is meshing internally with gear B. Therefore, radius of gear D plus diameter of gear F is equal to radius of gear B. Now making use of the same equation where radius is equal to modulo the number of teeth by 2, we will finally getting number of teeth on gear B is equal to 62. So we will make a note here. So this is it. This is the first part. Now let us focus on the main part of the question. That is, we need to find the velocities of gear B when there are two conditions. So we will first look at completing this table over here. Now, as we had discussed in session 2, the table will have 4 active rows, each row for each step, and where the steps are fixed. And the number of active columns that will be equal to the number of elements that are there in the given gear tree. Over here, we have arm, we have compound gear C, D. Now, even though C and D are different gears, but since it is a compound gear, we will be treating C and D as one single compound gear. So, element arm will be one element, compound gear CD will be my second element, this gear E over here will be my third element, this gear F over here will be my fourth element, this internal gear B, which is denoted in green color, this will be my fifth element, and my gear A will be my sixth element. So therefore, total number of columns or total number of active columns in the table should be equal to 6, because there are 6 elements in the gear tree, and number of rows in my table should be equal to 4, corresponding to the 4 steps that we are going to carry out. Once again I am repeating that the structure of the table will be same for all sums. Only variation will be in the number of active columns that will be there. This number of active columns will be equal to the number of elements that are given in the particular sum that is given to you. In this sum, since there are 6 elements, therefore number of active columns is equal to 6. If there were only 4 gears in a gear tree, then, or if there were only 4 elements in a gear tree, then the number of active columns would have been equal to 4. So the first column will always be reserved for the arm. The second column over here we have a choice which gear has to be selected, and there is no restriction on which gear to be selected. You can choose any gear of your own choice. Let us select compound gear CD. Once again, C and D, though they are separate gears, but since it is a compound gear, and since therefore the velocity is the same, we are going to treat it as a single element. So this gear, I will reserve it for gear CD. That is compound gear CD. Now, gear C is meshing with gear E. So over here, I will write this is for gear E, and gear E is meshing with gear A. So here I will write this is for gear A. Now, gear D that we have over here, gear D is meshing with gear F. So this column, I will reserve it for gear F, and gear F is meshing internally with gear B. So this column will be reserved for gear B. What is the first step that we need to do? Arm fixed, gear rotates through one revolution in the anti-clockwise direction. Arm fixed, which means the speed of rotation of the arm will be 0. Now, which gear rotates through one revolution? The very first gear beside the arm in this particular table. In this table, beside this arm, we have mentioned gear CD. So therefore, arm fixed and gear CD rotate through one revolution anti-clockwise. So therefore, the speed of gear CD is 1 because it is rotating with the speed of 1 revolution. Now in the given data, the velocity might be different, but we do not pay attention to the given data right now. Right now our focus is just on completing the table according to the standard 4 steps that we have. If gear CD is rotating with a speed of 1 revolution, what would be the speed of gear E? Here, gear C is this external yellow gear that you see. So gear C is meshing with gear E. We know generally when two gears are in mesh, that is when two gears 1 and 2 are in mesh, then N2 upon N1 is equal to T1 upon T2. N2 will therefore be equal to N1 into T1 by T2. Using the same relation where 2 is corresponding to gear E and 1 is corresponding to gear C, then speed of gear E, this will be equal to speed of gear C into ratio of number of teeth on gear C to number of teeth on gear E. Simple. Now, since speed of gear C is 1, so I will replace this by 1, or I will not write it only, I will just remove it. Therefore, if CD is rotating with the speed of 1 revolution per minute, then gear E will be rotating with the speed of Tc by T. So I will remove this NE also, now this is not required. Now, gear E is meshing with gear A. Then, speed of gear A, this will be equal to speed of gear E into number of teeth on gear E to number of teeth on gear A. From where did I get this equation? I am getting it from this relation that I am having over here. Now, speed of gear E is equal to Tc by Te. So I will copy this from here and I will replace this here. Now since there is a lot of confusion because there is too little space, I will remove this Na from this particular term. Now if you look, this is Tc by Te into Te by Ta. So we have Te in the denominator and here we have Te in the numerator. This Te and this Te will cancel out each other and ultimately what will be left out is Tc by Ta. Similarly, completing this table, here gear F is in mesh with gear D. The speed of rotation of gear D is 1 revolution. Therefore, speed of rotation of gear F will be equal to speed of rotation of gear D into number of teeth on gear D to number of teeth on gear F. Now, since Nd is 1, I will remove this term from here. This is simply Td by Tf. Now, gear B is in mesh with gear F. Therefore, speed of gear B will be equal to speed of gear F into number of teeth on gear F to number of teeth on gear B. Now, speed of gear F, from here we know speed of gear F is equal to Td by Tf here Tf is in the denominator, here Tf is in the numerator, so this Tf and this Tf will cancel out each other and ultimately we will be left with the speed of gear B is equal to Td by Tb. So we will remove this Nb also because now that is not required, that was just for explanation purpose. So we have over here, that is when arm is fixed and compound gear CD is rotating with 1 revolution, then gear is rotating with the speed of Tc by Te, gear A is rotating with the speed of Tc by Ta, and similarly. Now, we need to add signs to it. Signs because here they have said that the compound gear is rotating with a velocity of 1 rpm in the anti-clockwise sense. So, anti-clockwise sense will mark it as positive. So, here I will add +1 to indicate that it is rotating in the anti-clockwise sense. Now, gear C is in mesh with gear E. So, when gear C will rotate in the anti-clockwise sense, gear E will be rotating in the clockwise sense. Therefore, to show that it is rotating in a clockwise sense, I will add a minus sign over here. Now, gear E that we have, gear E is meshing with gear A internally, which means speed of rotation of gear, direction of rotation of A and E will be same. Therefore, since E is clockwise, A will also be clockwise. Therefore, I will add a minus sign to indicate that it is in the clockwise sense. Now, let us come to gear F. Gear F is meshing with gear D. Gear D is rotating in the anti-clockwise sense. Therefore, since F is meshing externally with gear D, the speed of rotation or the direction of rotation of F will be opposite to that of D. So, since D is anti-clockwise, therefore F will be clockwise. So, I will add a minus sign. And gear F is meshing internally with gear B. Therefore, direction of rotation of gear B and that of F will be same. F is clockwise. Therefore, gear B will also be rotating clockwise. So, we have completed step 1. Now, let us complete step 2. Step 2, simply it says multiply all elements in step 1 by x. So the elements that I have in step 1 are all this data that I have calculated or I have entered in step 1. I will copy it to row number 2 or to step 2 and I will multiply each of this term by x. So 0 into x is 0 itself, so I will not make any changes over here. Here 1 into x will be equal to x, so I will replace 1 by x. Now here x into the term Tc by Te, which is nothing but x times Tc by Te. Likewise, I will make all substitutions over here. That is what I am doing. I am multiplying throughout by x. So this will be x into Td by Tf and this is x into Td by Tb. This is step 2. Step 2 is complete. Now step 3 that we have is the most simplest of all. In step 3, we simply need to add plus y to all these empty cells that you see. So over here, this should be plus y, plus y, plus y, plus y, plus y, and here plus y. Step 3 is over. Very simple. Step 4. Step 4 is actually the total motion for arm, gear, gear E, gear A, gear F, etc. So what needs to be done in step 4 is we need to add the data cells in step 2 and step 3. That is total motion is equal to step 2 plus step 3. Over here it will be therefore y plus 0, which is y itself. For gear CD, this will be equal to y plus x. This y is capital, so I will just make it small over here. Here adding the cells in step 2 and step 3, so this will be y minus x into T C by Te. Here this will be y minus x into Tc by Ta. For gear F, it will be y minus x into Td by Tf, and for gear B, it will be y minus x into Td by Tb. Step 4 is complete. So this is automatic capitalization. I will just make it small once again. Yeah. So step 4 is complete. Now what does this term in step 4 indicate? It simply means arm is rotating with the speed of y rpm. Compound gear CD is rotating with the speed of y plus x rpm. Gear A is rotating with the speed of y minus x into Tc by Te rpm, and similarly gear A, gear F, gear B are respectively rotating with the speeds that you see. Now to find out the actual values of these speeds, we need to find how much y is and how much x is. To find how much y and x are, we have some data that is given to us. That is, if the arm is rotating with a speed of 100 rpm in the clockwise sense, that is if ng, where g is denoting the arm, so ng is the speed of arm, it is equal to minus 100, and if the internal gear A is stationary, which means na is equal to 0, then how much will nb be? So here the first thing that they have given to us is that arm is rotating 100 rpm clockwise. Arm is rotating with a speed of 100 rpm clockwise. So this will simply mean speed of arm, which is nothing but g, is equal to minus 100 because it is rotating in the clockwise sense. Now speed of arm over here is denoted by y. Therefore it means y is equal to minus 100. So now we have the value for y. Now we need to find the value for x. To find the value for x, we will take help of the second data point that is given to us in the first condition, that is gear A is stationary. Now gear A is stationary. So let me just enter it over here. Gear A is stationary, which means a spelling error. Yeah. Is the spelling correct? S-T-A-T stationary. Yeah, I think it is correct. So gear A is stationary, which means n suffix a is equal to 0. Now how much is na from this table? This last row corresponding to gear A column. So na is this term, that is y minus x into Tc by Ta is equal to 0. That is what we are saying. No? Since gear A is stationary and the speed of gear A is denoted by this term, so this complete term has to be 0. Or the value of y and x has to be such that this term becomes equal to 0. Now y is equal to minus 100. Making substitutions over here, we will be getting the value of x. Value of TC and TA we know over here, where TC is equal to 28 and TA over here we know, we have calculated, so this is equal to 64, and this y we have calculated in the previous step and it is equal to minus 100. We are getting it from here. So in this equation only x is the unknown and we will be getting x, and here and y we have calculated to be minus 100. So y is equal to minus 100 and x is equal to. Now once you do this calculation, I am not doing it over here. Once you know how much y and x is, you can simply find out how much NB is, that is speed of gear B. So speed of gear B is denoted or is represented by this particular term. So speed of gear B will be equal to this value over here. Now y is equal to minus 100. Value of x I haven't yet calculated, but you need to calculate and substitute it over here. TD is the number of teeth on gear D, so that is equal to 26. TB is the number of teeth on gear B, which is equal to 62. Since all terms will be known, finally you will be getting speed of gear B, this value over here, this is equal to minus 4.15 RPM. Since it is minus, it means it is equal to, it is rotating in the clockwise sense, so I will write it as 4.15 RPM, and bracket to indicate the sense I will write as clockwise. So we get, if the arm is rotating in the clockwise direction with a speed of 100 RPM and if A is stationary, then velocity or speed of rotation of B is 4.15 RPM clockwise. Now similarly, we can find the speed of gear B if gear A is rotating in the clockwise sense with a velocity or with a speed of 10 revolutions per minute. That is, how do we go forward? We make use of the same table that we have over here. So we have said that gear A is rotating with a speed of 100 RPM in the clockwise direction. Arm is rotating clockwise with speed 100 RPM, which means NG, that is speed of arm, is equal to minus 100. In this table, speed of arm is denoted by y, so that is plus y, so y will be equal to minus 100. Next thing that they have given to us is that gear A is rotating in the anti-clockwise direction. Now gear A, NA is equal to plus 10, since it is rotating in the anti-clockwise direction with a speed of 10 revolutions per minute, and value of gear A or speed of gear A is denoted by this term that we have, that is y minus x into TC by TA is equal to plus 10. Now you substitute y, you substitute TC, you substitute TC, you will be getting how much x is equal to. Now once you get the values of y and x, you can say directly calculate the value of gear B. Value of gear B will now be equal to this term that I have over here, that is y minus x into TD by TB, substituting all relevant terms, and finally you will be left with the answer that gear B will be equal to around 5 RPM. I am not, let me just check my notes how much it is. Yeah, so it is 5.4 RPM. So here it is plus 5.4 RPM. So what it means is, this is rotating with a speed of 5.4 RPM in the anti-clockwise sense. So I will not write anti-clockwise sense, I will just keep it as anti-clockwise. That's it. Thank you.